All right, section 2.6. So this is the last section of the kind of review stuff where we're looking to just kind of remind you that you've done most of this before. If you've done some of the simpler ones, we're going to add a couple of the difficult ones. That kind of scenario where we're looking for being able to just kind of look at a situation, look at a math problem, and come up with a solution for that problem. How do I start it? How do I get there? So this is just a couple of kind of the special cases, the quote unquote weirder ones. So let's look at rational exponents. Okay, one of the biggest things that you're going to want to know how to do for this entire class is manipulate exponents. It's going to happen all the way through the rest of class. There are going to be exponents everywhere. We're going to change them to fractions. We're going to change them to decimals sometimes. We're going to create multiple things in the exponent. We're going to have exponential things where the exponent does its own scenarios. So if you're not 100% comfortable with exponents, I definitely, absolutely 100% recommend that you go back and review that material. If you want to, you can look up Khan Academy. Is a decent place to go and see if you can. They have like little videos and review modules and some practice problems and things like that. Look up Khan Academy. The exponent rules are usually in his Algebra 2 lessons. Okay, so you want to make sure that you are looking at everything you can do with exponents. What we're going to focus on right now are rational exponents. So what a rational exponent is we are looking at taking a square root and changing it into an exponent, or taking an exponent, putting it back into a square root. Okay, so all 5 of these things right here mean exactly the same thing. They just happen to be different ways to write the same scenario. Okay, so it is always your variable or whatever you're looking at to the power over index. Okay, and what that means is that the power is the exponent and the index is whatever I'm taking the root of. So if I'm taking a 5th root of something, the index is going to be 5. If I'm raising something to the 8th power, then the power is 8, right? So your index is the square root, the power goes on top, or the index comes from the square root. Okay, now all of these things apply whether I have just a letter there or if I have an expression. So this could be something like x squared minus 5 plus 2y, right, raised to the 3/2 power. And that would be the square root of x squared minus 5 plus 2y cubed. Okay, so all of these things apply regardless of what the thing in the parentheses is, regardless of what that base is. Now, this is not x to the 3, no, let me say that, x squared to the 3/2 minus 5 to the 3/2 plus 2y to the 3/2. Okay, it is not that. That is not how that works. And if that's what your brain wants to do, absolutely 100% go back, find 20, 30 minutes, go review those exponent rules. Download a cheat sheet so that you can figure out what it's asking you to do. You cannot make that mistake or it's going to mess you up for the entirety of this whole semester, okay? Not this. Everything inside that base stays together. Okay, now without a calculator, we can solve these. We can actually simplify a lot of these. And typically what we want to do is we usually, and this is not an always, we deal with the index first. Okay, and then raise it to whatever power is given to you. Okay, the reason we do things in that order is because the index is the root. It's a root of something, so it's going to make that number smaller. And then once I have a small number, I can raise that back to a power, and that's a lot easier for like mental math or even on your calculator, that's a lot easier than trying to take 27 and square it, which I don't know off the top of my head, and then try to take the cube root of that giant number, right? So we don't want to get too crazy where we don't have any idea what's going on anymore. We want to make sense of these things by saying, all right, well, I know the index is 3. So this is going to be the cube root of 27. And once I find the index, I'm going to square the answer. And I know the cube root of 27 is a 3, because 3 times 3 times 3 is 27. And then if I square that, that's a 9. So we can do that somewhat mental math, right? Go to the next one. I have 4 to the 5 halves. So that would be the square root of 4 raised to the 5th power. The square root of 4 is a 2. 2 to the 5th power is going to be 2 times 2 times 2 times 2 times 2, right? So that's going to be, I believe it's a 32. Okay. Now, it doesn't always work that nicely because the base on all of those is a number. And if the base is a number, we can go really straightforward, got all the information I need, no big deal. Okay, but now I've got situations where that base is an exponent. So what do we do? Well, we're going to start the same way. We're going to say, actually I'm going to bring this over here. X to the 5/4 is 32. Okay? So this is the 4th root of x raised to the 5th power. Okay? And then this is where it can get a little bit confusing. Order of operations says parentheses first, then exponents. When I'm solving something, when we're solving for x, we do order of operations backwards. So instead of doing the parentheses first and then the exponent, when I solve, I want to take care of that exponent first, then I can deal with what's in here second, right? If I'm undoing, we do order of operations backwards. So I'm going to take a 5th root of both sides. Okay, so that leaves me the 4th root of x on the left. The 5th root of 32 is 2. Okay, that's over here. Now I can undo the 4th root. So we do that by raising things to the 4th power. So the 4th root of x raised to the 4th power is going to just be x. And 2 to the 4th power is going to be 16. Okay, so that's the long version of what we're doing. This tells us x is 16. Now, the reason we have rational exponents is because we can actually get there a little bit quicker. So let's take x to the 3/2 equals 216. Now we took a 5th root, right, and raised it to the 4th power. We started with a 5th power and a 4th root, okay? And we ended with x to the 1st power. So your goal is to have that variable be to the 1st power. And when I have a fraction, the way to make it equal a 1 is to raise it to a reciprocal. And if I do that on the left, I have to do the same thing on the right. Okay, so over here, 3 times 2 is 6, 2 times 3 is 6. On the right side, I've got the cube root of 216 squared. So 6 over 6 is a 1, so that gives me x. The cube root of 216 is a 6. If you don't know that, that's fine. Do it with a calculator. So then this is 6 squared, which means x is 36. Okay, so you can save a step by using the powers as fractions and using the idea of reciprocals and thinking about what exponent do I want there, and kind of working your way in that direction. Okay, I'm going to erase some of this real quick. All right, so the next one I've got is 3x to the 3/4 equals x to the 1/2. Now this one gets a little weird. Okay, this one definitely has weirdness to it because I have an x on both sides. Okay, and what the x on both sides does is it creates that scenario where if I use a reciprocal, it might not work. It's not actually going to make anything easier. Okay, for example, if I take a reciprocal on the right and I raise this to the 4/3, I also have to raise 3 to the 4/3 because of the rules. The rules of exponents say everything on the side has to get raised. So it does make an x to the first power over here, but over here, it actually makes that a 4/6, which is not easier, right? So we haven't fixed anything by that. And if I do the same thing in the opposite direction, where I just raise everything to the second power, right, 2/1, it doesn't get rid of anything on the left power. I still have a fraction there, and I don't want one, okay? So what we're going to do here instead, get rid of the stuff that doesn't work. Got rid of too much there. Is we're going to pick a common denominator for your indexes. Okay, the two indexes here are a 4 and a 2. So we're going to pick something that is common to those, i.e., what number can I multiply both of them into, or divide both of them by, whatever terminology sticks. Okay, and in this case, it's going to be a 4. Now I could use an 8, I could use a 12, I could use a 400. You just pick one, okay? Ideally, it's the smallest one, but it's okay if it's not. It's going to work either way, okay? And what we're going to do with that 4 is we're going to take both sides and we're just going to raise them to the 4th power. And as long as I do exactly the same thing on the left as I do on the right, this is fine, okay? So this 4 goes to the 3. So I have 3 to the 4th power. The 4 goes to the x to the 3/4. So it's going to be 3 times 4 over, you can put this over 1 if that helps. Okay, so x, 3 times 4 is 12. 12 over 4 is going to be a 3. On the right side, 1 times 4 is 4. 4 over 2 is a 2. And now I've got this. Okay, now at first glance that might not look like I made it easier, but I did. Okay, I promise this actually got easier. Now, since there are multiple x values, and they are raised, or multiple x terms, sorry, I probably shouldn't call them values, multiple terms that have a variable in it. Okay, the only way to solve this is to factor. That is your only solution, your only path forward. Okay, since that exists, I have to factor. So that means I need to set it equal to 0. I'm going to raise 3 to the 4th power first. So 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is an 81. Okay, I'm going to subtract x squared from each side so that that is equal to 0. Now I have to factor this. So I'm going to take a greatest common factor because that should always be the first thing we look for. Both of these terms have an x squared. And that leaves behind 81x minus 1. So either x squared is equal to 0, or 81x is minus 1 is equal to 0. So over here, I can take a square root of both sides, just gives me x is 0. This is 81x is equal to 1. Divide by 81. So x is 1 over 81. Okay. Multiple terms with an x in them, multiple answers, that's fine. That makes sense. Okay. That is the only way to solve if you have multiple x values. Okay. I'm going to erase some of this so we can go to the next one. All right. So I've got x plus 5 to the 3/2 equals 8. Now, just because I have a whole set of, I have a whole binomial in here, I have a whole expression, it doesn't change how you're going to approach this, okay? The entire left side is raised to the 3/2. Just like the last one, if I was doing order of operations, I would deal with the inside of the parentheses first, then with the power. But because I'm trying to solve, I want to deal with the power first. So I'm going to take both sides and raise them to the 2/3. Okay. And so on the left side, what that's going to leave me is x plus 5. On the right side, if you have a calculator that will do exponents, that will do those types of things for you, great. You can type this in. But when you put this in a calculator, you need to make sure that both the 2 and the 3 are in the exponent. Okay? It will sometimes look like this. And you need to make sure that this set of parentheses is there. Without it, your calculator is going to square that 8 and then divide the number by 3 instead of finding a cube root. So you need to make sure that when you are typing that in, you're typing it in correctly. And you can practice on the ones on this page and make sure if you can put in these 3 correctly and you're getting 9, 32, and when you do this one, you should get a 2. I'm sorry, you should get a 4. If you're getting those 3 answers, you're using your calculator correctly, and continue to do it that way. If you're not getting those answers, send me an email, put something in the discussion board, whatever it is, and let's figure out how to make sure that you're getting the right answers. Okay. So x equals, let's see, subtract 5 from each side means that x is -1. Okay, so we're coming up with solutions by undoing rational exponents. All right, once I have rational exponents, then we have to go back and look at radicals. What do I do with radicals? Okay, a radical, the word radical, is another name for a root. Okay, you are looking at nth roots of something. Okay, 4th roots, 5th roots, 12th roots, 132nd roots. Okay, we just call them radicals. Or we occasionally will just say something like rad. Okay, mathematicians are lazy. What can I say? We just like to find the fastest, most quick way to do literally everything. So a lot of times these things get shortened, and I use the shortened versions, and I apologize, but I will let you know I'm using rad to mean a square root or a cube root or whatever root. Okay, now the big thing with radicals is check your answer. Okay, when we are working with radicals, what happens is that we are going to square things, or we're going to raise things to even powers. And when we do that, what we are accidentally doing is we're introducing a solution that might not exist. Okay? And the reason for that is that even powers always produce positive answers. Okay, so if I square something, my answer should always be positive. If I raise something to the 8th power, my answer will always be positive. It doesn't matter if I'm squaring or using a positive number or a negative number, right? If I'm using a positive number, then I have positive times positive times positive times positive times whatever, how many positives. And I'm always going to end up with a positive answer. If I'm using a negative number, like say I take a -4 and I raise it to the 6th power, that's -4 times -4 times -4 times -4 times -4 times -4. Well, negative times negative is a positive. So then this negative times negative is a positive. And this negative times negative is also a positive. So I'm actually just multiplying 3 positive numbers, and my answer is going to be positive. So it doesn't really matter what I'm multiplying. But because the way to solve a square root is to square things, we're accidentally making things positive that might not actually exist. Okay? And in a graph, if you want to think of it like a graph, if I square, say I have a function that looks like this. If I square that function, what we're basically doing is we're taking everything over here that was negative and we're kind of pushing it back like that over the top of the function. And so if I plug that number back into my regular function, even though it exists on this green line, it doesn't actually exist where the line was when I started. So always, always, always check every single answer, plug it back in, make sure that you get an answer that works. Okay? Every time. Without fail, just do it. All right, so let's say I have a square root. I need to solve the square root of 5x minus 6. Now you can write this as a rational exponent if you prefer. You can do 5x minus 6 to the 1/2 equals 12. You don't have to, okay, but you can. It's up to you. Either way, the next step is going to be to square both sides. So I'm going to take that entire side and square it. I take this entire side and square it. So the square of a square root is going to be 5x minus 6. 12 squared is 144. So we add 6 to each side. So 5x is 150. And we divide by 5. So x is 30. Plug it in, go back and check. Now the only part you really have to check is the square root portion. So I take 5 times 30 minus 6. So 5 times 30 is 150 minus 6, which is the square root of 144, which we know is 12. Okay, now it was on the last slide, but I didn't say it out loud. We are using the principal square roots only for this application. There are no imaginary numbers. There are no square roots that give me negative numbers either. Okay, so for this application, it's principal square roots only, which means no plus or minus when you do a square root. Okay, when we're working in the world of imaginary numbers, the square root of 144 is plus or minus 12. When we're solving these, the square root of 144 is 12. All right. I've got another scenario here. I have a thing squared, I have x minus 7 equals the square root of a thing. First thing you want to do, and we didn't have to do it last time because it was already there. Okay, we want to isolate your square root. Whatever is in the square root goes all by itself. If it's being multiplied by something out front, divide that away. If I'm adding to it, subtract that away, or vice versa, okay? Get the square root by itself. Once you have it, then we're going to square both sides. Make sure here that you distribute a binomial. And I will show you what I mean. When I square both sides here, the left side is x minus 7 squared. This is a binomial. It means I have two things and I'm adding or subtracting them. When you square a binomial, the same way that if I say 4 to the third power is 4 times 4 times 4, this binomial squared means I'm doing x minus 7 times x minus 7. I am not doing x squared minus 7 squared. Okay? Distribute your binomials. So x times x is x squared. X times minus 7 is minus 7x. Minus 7 times x is minus 7x. Minus 7 times minus 7 is a positive 49. On the right side, I have x minus 1 squared. So that's just going to give me an x minus 1. So the left side is x squared minus 14x plus 49 equals x minus 1. I have multiple x terms. And one of them is at least x squared. So that tells us the only way to solve this is to factor. So I'm going to take x squared, I'm going to subtract x from each side, add 1 to each side. Sorry, that should be a 49. So now that it's equal to 0, I can factor. The first term has a coefficient of 1, so I can just look for factors of 50 that add up to negative 15, which is going to be x minus 10 and x minus 5. So either x minus 10 is 0 or x minus 5 is 0, which means x is 10 or x is 5. Okay, now we plug them back in and double check. Let's see, I'll start with 10. So if x is 10, then 10 minus 7 is equal to the square root of 10 minus 1. So 10 minus 7 is a positive 3. 10 minus 1 is 9. So that one works out. Okay. If x is 5, then 5 minus 7 is going to be the square root of 5 minus 1. So 5 minus 7 is a negative 2, which is the square root of 4, and that does not work. Okay, remember, principal square roots only. So when I take the square root of 4, I get a positive 2, and those are not equal. And so what we do with our answers is I say, well, 10 works, and we just draw a line through 5. 5 is what is called an extraneous solution. Okay, and it's created because I squared both sides. Now, when you do this, always check both numbers. It is 100% possible to have two answers and neither one of them works. It's 100% possible to have two answers and both of them work. So always, 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 always check it. Plug them in, plug in all of them. Sometimes one works, sometimes none of them work, sometimes both of them work. Okay. All right. What do I do if I have two square roots? Well, this is where it gets so exciting. You still start the same way we did the last one. We're still going to start by isolating one of those square roots. It doesn't matter which one, just pick one and get it by itself. Okay, I don't like subtraction, so I'm going to add this thing to both sides. Okay, so the left side now I've got the square root of 2x plus 3. The right side is 2 plus the square root of x plus 2. Now I wrote it what appears to be backwards, I did that on purpose. I don't want to accidentally write the square root of x plus 2 and have this little tail right here be too long and confuse me into believing that this 2 is actually inside, because it's not. So I have found the best way to do that is to just put that 2 out front, and then I don't have to worry about it. Okay? So we do that with square roots a lot. We put them at the end so that we don't accidentally confuse ourselves. Okay? Now, once the square root is by itself, we are going to square both sides. And again, FOIL or distribute. It just is going to look so messy this time, but we're going to do the same thing. So we're going to take this entire side and square it. We're going to take everything on the right side, put it in a parenthesis, and square it. Okay. Again, this is not 2 squared plus x plus 2. We're taking the entire side and squaring the whole thing. So when I square the left, that one's easy. I just end up with 2x plus 3. But on the right, I'm doing this thing times itself. And it does get messy, okay? You just have to be patient with yourself. You have to keep going and let it be messy. So we start with 2 times 2, which is 4. And we do 2 times our square root. So 2 times our square root, and then 2 times the square root, and then the square root times itself. So I have the square root of x plus 2 squared. Okay, now this becomes a 4. The square root of x plus 2 squared is going to be plus x plus 2. These two things are like terms. They have exactly the same variable setup. And I have 2 of them on the left plus 2 more of them. So this is going to be plus 4 times my square root. Okay, so all of that together gives me x plus 6 plus 4 of the square roots. And on the left, we have 2x plus 3. And at first glance, you're going to think that did not get easier. And that's fair. That's a fair reaction to that. It doesn't look like it's easier. But then when you go back and look a little closer, I started with 2 square roots, and now I only have 1. And that means we're making progress. Okay, we've gotten halfway to the answer, right? From 2 square roots down to 1. So now I just have to get rid of that other square root. So we're going to go back and we're going to repeat this cycle. I'm going to isolate this square root again. So we're going to make sure that this thing that's now in the box is all by itself. Okay, so I'm going to subtract x. I'm going to subtract 6. So 2x minus x is x. 3 minus 6 is a negative 3. So this is 4 times my square root. Now, very common mistake is to subtract that 4. I can't subtract it. It's being multiplied. This is 4 times that. So we undo multiplication with division. I'm going to change colors just to kind of break things up here. So now I have the square root of x plus 2 is equal to x minus 3 divided by 4. Now again, you're going to have that like, holy crap, this is not easier reaction. That's fine. You can react that way. Nobody likes fractions, but fractions are part of life, and I can't make them go away entirely, so we've got to figure out how to deal with them. Okay. All right, square both sides to get rid of that square root. So on the left side, we have x plus 2. Now on the right side, again, back to those exponent rules. When I square a fraction, I can square the numerator and the denominator separately. So I can treat this like x minus 3 squared over 4 squared. And that helps the denominator. It does help the denominator go a lot faster. But it also reminds us that this is x minus 3 times x minus 3 over 16. Okay, so x plus 2, and I'll FOIL that out for you so you don't have to worry about it, but just know that's what I did. So this is x squared minus 6x plus 9 over 16. And then if I take both sides and multiply them by 16, on the right side, the 16 in the denominator is going to cancel out the 16 in the numerator. On the left side, I've got 16x plus 32. On the right side, I've got x squared minus 6x plus 9. There are no square roots left, which means we're on the right track. We're doing the right thing. We're going the right direction. Now, I do have multiple x terms, and one of them is squared, which means I've got to factor. And in order to factor, everything has to equal 0. So 0 is x squared. If I subtract 16 from both, 16x from both sides, gives me a minus 22x. Subtract 32 from both sides, and that gives me a minus 23. And then we factor. So this is x minus 23 times x plus 1. So x minus 23 is equal to 0, or x plus 1 is equal to 0, which means either x is 23 or x is negative 1. Okay. Don't forget to check your work. So we're going to go all the way back to the beginning. And since I'm out of room, I'm going to erase some down here. Okay, we're going to go all the way back to that original equation. And I'm going to start with 23. So this is the square root of 2 times 23 plus 3 minus the square root of 23 plus 2. So 2 times 23 is going to be 46. 46 plus 3 is going to be 49. 23 and 2 is 25. So this is 7 minus 5, which equals 2. So 23 works. And then we're going to check negative 1. So the square root of 2 times negative 1 plus 3 minus the square root of negative 1 plus 2. So 2 times negative 1 is a negative 2. Negative 2 plus 3 is a positive 1. Negative 1 plus 2 is also positive 1. So this would be 1 minus 1, which equals 0. Now I wanted it to equal 2. Since it doesn't, negative 1 is my extraneous solution, and 23 is my actual answer. Okay. Now remember, you can pause this, you can rewind this, you can go back, you can look at it again, you can post questions on the discussion board, you can come to office hours, you can do all of those things. Okay. All right, and then the last one in this section is absolute value. So what do we do with absolute value? How do I deal with that? What even is absolute value? Well, if you look at the graph of an absolute value equation, what an absolute value does is the equation looks like this until we transform it. And we'll talk more about transformations in chapter 3. But until I transform it, every single answer that comes out of an absolute value equation is going to be a positive number, right? Everything that comes out of an absolute value is a positive number. Now, the other thing to remember is that absolute value bars are not parentheses. So I can't treat them like parentheses. I can't multiply them into, okay, so don't distribute into an absolute value bars, and don't factor out. Okay? The only way to get rid of absolute value bars is that you have to look for cases. I always want to write look. Okay? You get the absolute value by itself, and then we analyze. You have to think very critically. I have an absolute value bar. On the other side, I have an answer. Could it be one answer? Could it be two answers? Is there even an answer? Okay. If the thing on the right side, which we're going to call C, okay, C is just whatever's over there. It could be an expression, it could be a number, it could be another absolute value. I won't do that to you, but it could be, right? So whatever is over there, if it's a negative number or something that we know is going to be negative every time, then that absolute value doesn't exist. I can't do that, right? The whole point of an absolute value is to make things positive. So if I take the absolute value of something, I can't get a negative number. So that one's we just say it doesn't exist. Okay? If it's exactly equal to 0, then I have one case, because there is no such thing as positive 0 or negative 0. Right? I can't do that. Well, I can, it just doesn't make any sense. So there's one case, and we just kind of drop the bars and we solve it as it's written. However, if the number or the expression or the thing on the right side is positive, then we have to split it into two cases. One case that has an answer on the right side, and the same case with an answer on the left side. Now, when you look up written examples in XYZ, it is going to do this the opposite way that I do it. I'm going to tell you, please do it the way that I'm showing you. It is easier, I promise. Okay? What they do in XYZ is they make the absolute value positive and they make the absolute value negative. And what happens is that when you make that absolute value negative, you have to drop the absolute value bars and then distribute that negative as if it's a parenthesis, or your answers are going to get messed up. If you do it my way, there's none of that. You just drop the bars and you have a negative number on the other side. Okay? I promise you it is mathematically sound. I promise you the way that I'm doing it is easier. Okay? All right. So, looking at these absolute values that I have, I've got the absolute value of 6x plus 4 equals 8. So then I look at my cases. The thing over here is an 8. 8 is a positive number. Cool. What that means is I'm going to write the absolute value portion twice. Okay, you're just going to copy that down in both locations. Then you're going to take your answer and put it in one place as written. So here as a positive 8. And then over here, you're going to add a negative and put it on the other one. And then you just solve this. So 6x plus 4 equals 8. Means that 6x is 4. Divide both sides by 6. So x is 2/3. Over here we've got 6x equals, subtract 4 from each side, negative 12. Divide by 6. So x is negative 2. Okay. Now you should check your absolute values. I'm pretty sure most of them work. If it doesn't work, it's because you missed the case where you had a negative number to start with. Okay, so as long as you did your cases correctly, you should have an answer that works. If you're not sure, plug it back in and check it. You can always do that with math. Plug it back into where you started and make sure that it falls out and becomes the answer that you thought it was. Okay. All right. This other one, we've got absolute value isolated. Great. Step one is done. So we're going to look at our C value. And in this case, it's a negative number, right? C is less than 0, which means this solution doesn't exist. I can't do anything. The absolute value is never going to give me a negative number, so there's no solution there. Okay. All right, I'm going to do the one on the right first, just for to kind of give you all three examples first. Right side, I have absolute value. It's isolated. It's all by itself. Cool. Over here, I have a 0, which means there's only one case, because I can't have positive 0 and negative 0. So all we really have to do is just pretend the absolute value isn't there. Okay, so subtract 10 from each side, divide by negative 5, so x is 2. Okay. Now the example on the left, I have an absolute value, but things are happening with the absolute value. It's not by itself. So in this scenario, I'm going to take that box and I'm just going to write this so that you can see it. You do not have to do this part. Okay. Now if that box, flashback to elementary school where we used to just leave you a box to kind of work your way backwards and figure out what goes there, we're doing the same thing. Here's your box. Figure out what goes there. Well, the thing that goes there, to find it, I would add 8 to both sides. So now I have 2 of the boxes equals 20. Then I would divide by 2. So the box is 10. When you are isolating absolute values, I want you to think of it that way. I cannot, under any circumstances, well, you can in higher levels of math, do not multiply that number in. Okay? Do not. No, don't do that. Do not do this. Okay? Do not subtract that 8 inside. Do not add 5 outside. Okay? The absolute value is a unit. It's a group, and it has to be by itself. It has to travel on its own. Otherwise, you're going to get everything all messed up and mixed together. Okay? I'm going to erase my example over here so I don't have to erase that. All right, so now that the absolute value is by itself, I'm going to rewrite this. So it says the absolute value of 3x minus 5 equals 10. Okay, if you want to do it with the absolute value there, great. If you want to change it to a box and get it by itself and then change it back, great. I'm not going to fault you either way. Whatever makes sense in your process. Okay, so I'm going to look at the C value. The C value is a positive 10, which means I have 2 cases. I'm going to take 3x minus 5 and write it twice. On one of them, I'm going to put the 10. On the other one, I'm going to put the negative 10. Okay. Add 5 to each side. So 3x is 15, which means x is 5. Over here, add 5 to each side. So 3x is a negative 5, which means x is negative 5/3. Okay. As long as you split your cases correctly, both answers should work. Okay. I want you to pause the video and I want you to try this one. Isolate the absolute value, solve, treat it the same way as the example we just did. See if you can get all the way there. Once you have an answer, press play again, and I'll show you the answer. All right, I need to get the absolute value by itself, so I'm going to subtract 16 from both sides. So negative 8 minus 16 is a negative 24. And I'm going to divide both sides by negative 3. So the absolute value of 2x plus 4 is equal to positive 8. Now, this is why we isolate the absolute value first. At first glance, if I don't isolate it, this leads me to believe that the answer doesn't exist. Except that when I then do the math, now I've got a positive 8 there, and the answer definitely exists, and I need to go find it. Okay, so always, 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 always isolate it first. And I've got a positive 8, which means there are two answers. So either 2x plus 4 is equal to 8, or 2x plus 4 is equal to negative 8. So either 2x is equal to 4, divide both sides by 2, or 2x is equal to negative 12, divide both sides by 2. So I either get a 2 or a negative 6. Okay. Both of them are good. Both of them work because we split up our cases appropriately. All right, so the last bit of factoring, the last tiny little bit of factoring is I am looking at quadratic form. I want to still be able to factor things that maybe look different, that aren't quite the same. Okay, and when I do that, we are looking at a trinomial. Okay, 1, 2, 3 terms, so trinomial, where the biggest exponent divided by 2 gives me the middle exponent. And then the final term has to always be a constant. Okay, so 8 divided by 2 gives me 4. The last term is a constant. 6 divided by 2 is a 3. The last term is a constant. So all of these are considered quadratic form. Because if you look at a quadratic, 2 divided by 2 gives me 1, and the last term is a constant. And if I can make things look like that, I can still factor them. Okay? So here's some examples. 4 divided by 2 is 2, so I have quadratic form. Okay, and we can use something called U substitution to kind of trick our brains into like, oh yeah, we do know how to do this. Okay, you're going to take U equal to just the variable portion of the center term. Okay, if it's x cubed in the middle, it's an x cubed. If it's x to the 8th in the middle, U is x to the 8th. Don't worry about the number that's there. We just want to change whatever term is there, or whatever variable portion is there. Okay, so we're keeping our 3, we're keeping our 2, we're keeping the 1, but our variables are now, I have 2 of them in the first term, 1 of them in the second term. So I'm going to factor 3u squared minus 2u minus 1, which is a quadratic, which we've been factoring, and isn't as scary looking. Okay, if you want to factor these just using the x's and the x's squared, absolutely fine. If you need to change it so that your brain doesn't get intimidated, this is how we do that. Okay, so I need factors of 3 times negative 1, which is a negative 3, that add up to a negative 2. So it's going to be minus 3, positive 1. So this is going to be 3u squared minus 3u plus u minus 1. Take a 3u out of the first two, leaves me with u minus 1. From the second two, the only thing they have in common is a 1. So that leaves u minus 1. So u minus 1 times 3u plus 1. Now, if you subbed out the u, you need to replace u equals whatever you set it to. Before you use the zero product property, replace it. Okay, so this is x squared minus 1 and 3x squared plus 1. Okay, that makes a difference. It's going to change what we're doing when we solve. Mostly because x squared minus 1 is difference of squares, and it's their favorite difference of squares to use. It gets used all the time because we don't look at a 1 and think, oh, 1 squared is 1, so that's a perfect square. It is a perfect square. They're going to use it. They're going to sneak it in everywhere. It does follow difference of squares. So x plus 1, x minus 1. Now, none of these are perfect squares except for the x. And it wouldn't matter anyway because I'm adding, and sum of squares is not a thing. Okay, so it has to be subtraction or that pattern doesn't work. So from here, I'm running out of space, so I'm going to assume you went through the zero product property. So x is negative 1. From here, x is positive 1. And from here, you're going to get x is plus or minus square root of negative 1/3, which if you rationalize is going to give you plus or minus I rad 3 over 3. Okay. If you don't know how to rationalize, go back to Khan Academy, figure that out. That's not something we cover in this particular class. Okay, it goes with the exponent rules that you should have covered prior to this. So you did cover them in high school. It's just a matter of whether or not you remember them. If you need to go back and review them, go back and do so. Okay. Now I'm going to do the next one without the substitution. It's up to you. Okay, I just want to make sure that you guys have an example of each kind. So without substitution, I'm just going to treat this like I would any other quadratic. So a is 1, which means I need factors of 9 that add up to negative 10, which are going to be negative 9 and negative 1. The difference is, instead of having x in both of them, I have x to the half of this. Okay, so 4 divided by 2 is going to be a 2. So these are going to be both x squared, not just x. Okay, that's the difference. If you want to use substitution so that you don't have to remember that part, great. If you can remember that part, great. Do whichever one is easier in your brain. Okay, so now I've got two sets of difference of squares. So this is going to be x plus 3 times x minus 3. This is going to be x plus 1 times x minus 1. So this is going to give me x equals negative 3. This one is going to be x is positive 3, x is negative 1, x is positive 1. And if they want you to list them, oftentimes they want you to list them from smallest to largest. So make sure you're putting them in that order if they ask for that. Okay, it is one of the things that trips up students every year on XYZ or every semester. Make sure you read those questions really carefully because you might have the right 4 answers, but if you don't put them into numerical order, then you're in trouble. Okay, so make sure that they are in order from least to greatest and go from there. All right. Now, just to make sure that you're looking for the right patterns, they're occasionally going to throw a couple things like this at you, okay? They're going to say, oh, it's x cubed and x, that's 2 less. The rule isn't 2 less. The rule is divided by 2, okay? So here, this isn't really quadratic form, except that I can still factor it, okay? So not specifically quadratic form, but still factorable. So start with your greatest common factor. So I'm going to take out an x. So 4x squared minus 9. And then if I look really closely at what's in the parentheses, well, this is 2x squared. 9 is 3 squared. So that's difference of squares. It looks different than what we've been doing, but it's still difference of squares. So then that's going to factor into 2x plus 3 and 2x minus 3. And then those are going to give us some answers. So x is 0, 2x plus 3 is 0, 2x minus 3 is 0. So either x is 0, x is negative 3 halves, or x is positive 3 halves. Okay, so just because it's not exactly quadratic form doesn't mean I can't factor it. It just means I'm going to try to look for a common factor first and then see what's left over and go from there. Okay, for the next one, let's take out a common factor here. So they all have a 2 in them. I can take a 2 out of all of those. With the variables, they all have an x in them. So I'm going to take out a 2x. And that leaves me with x to the 4th. 16 divided by 2 is 8, x squared. 18 divided by 2 is 9. And now looking at this, that is quadratic form. Okay, I want factors of negative 9 that add up to positive 8. So I'd have x squared minus 9 and x squared plus 1. So 2x, this is difference of squares. So it's going to be x plus 3, x minus 3. This is sum of squares, so it doesn't factor. It doesn't mean it doesn't give me answers. It means it doesn't factor. Okay. So 2x equals 0 means that x equals 0. X plus 3 equals 0 is going to give me negative 3. X minus 3 equals 0 is going to give me positive 3. And then x squared plus 1 equals 0 is going to be x squared equals negative 1. Take a square root of both sides. So x is plus or minus the square root of negative 1, which we know is an I. So x is plus or minus I. Okay, so bigger polynomials can be factored. We just have to start looking for and trying to recognize some of the patterns that let us do that. Okay. All right, that's it for 2.6. I know it's a long one. Sorry, but here it is.